I'm now very briefly going to introduce Chuck Weiss, who is the Santa Clara County Superintendent of Schools. Before coming to Santa Clara County, he was the Superintendent of Schools in Ventura County. Chuck is a past president of ACSA, the Administrators Association, and served as a member of the Academic Standards Commission, which delivered their report to Ted Mitchell recommending that California adopt the Common Core standards. And Chuck will introduce the next panel.
Well, good morning. Well, those in the back haven't had enough coffee yet. Good morning. Welcome to Santa Clara County. And to Stanford. We won't make any shots at Stanford up here. Mohammed, not a good. The other thing you didn't mention is I'm also a member of the board of the Silicon Valley Education Foundation as one of the sponsors today, and we're very proud to be sponsoring this event today and having you all here. Mohammed didn't say it, but we have over 400 in the room, and we turned away more than that. So this is obviously an issue of great importance to all of us in education and something that we have decided to tackle and make a difference in. How many of you are not from Santa Clara County here today? So the majority of you are not. So good. I can tell you a little bit about our county. We have 260,000 students in over 400 schools, 31 school districts, and a robust charter school movement that's growing very rapidly and indeed is helping us to challenge the grammar of schooling. And you're going to hear from some of those leaders later today. The Silicon Valley Ed Foundation, I just want to say a few things about before I introduce the panel, has done a lot of work to both use, as Ted would say, synergistic as well as transformational or disruptive support to change the way we think about schooling. We're a partner with Khan Academy, and as Ted said, Khan is changing our grammar of schooling. It's changing the way we think about how students learn. And in fact, the major grammar that I want you to think about, because I only have a few seconds to tell you things, is a grammar of gradedness. The grammar of gradedness. That students are grouped together by manufacture age, by the date of manufacture rather than by what they know. And Khan Academy has given us the opportunity to say learning is a continuum, and especially in mathematics. And as students can move through that continuum of mastery of skills and knowledges, they can move to whatever pace that they're capable of doing. And so we have a person in the room here, Glenn Thomas. Glenn's a former Secretary of Education. I don't know where you are, Glenn, but I saw you earlier. And Glenn used to, when he spoke about this, said we should have any time, any place, any pace learning. And that's part of the grammar of schooling we have to think about as well. So as we go through this panel today, I hope you'll think about that. We have an august group of people to speak with you right now. But I only want to tell you one other thing. And as David said in his opening, this achievement gap is something that we've taken on seriously here in Santa Clara County. We have launched an initiative 2 years ago called SJ 2020, and it's an initiative to eliminate the achievement gap by the year 2020. We take it very seriously, and it's a collective impact model with everyone in the community working together, nonprofits, schools, charter schools, our local government. It's chaired by our mayor in San Jose, and we've now expanded it to all of Silicon Valley. We believe that by working together, we're going to find the solutions to make sure that all students can reach the high levels of achievements as our top performing students here in Santa Clara County. And one of the things that we know is that Algebra 1 is a gatekeeper and that many of our children of color and children of poverty are not getting to Algebra 1 at the same time. And so, led by Manny Barbera, who's one of the leaders here in the room, Manny's right over here, he has brought together the 7 feeder elementary districts to our largest high school district, Eastside Union High School District, and developed a common set of placement standards for Algebra 1, so that students are not being placed into Algebra 1 based on the color of their skin or their relative affluence, but are based on their ability to succeed in algebra and even get them ready to succeed in algebra. That's the kind of, I think, challenge to our grammar that we also are working on. Manny, you're a great leader, and we appreciate your work in that as well. So now let me bring up our panel. None of the people I talked about are on our panel, but let me tell you about who's on our panel. Some really wonderful folks. And as I mention your name, please come forward and take a seat. Not this seat, because it's mine. Okay. First one I want to bring up is Dr. Neal Finkelstein. Neal is an education researcher with West Ed who designs and implements rigorous field-based program evaluations and impact studies. Prior to joining West Ed, Dr. Finkelstein served as Director of Educational Outreach, Research, and Evaluation for the University of California Office of the President. Neal, thank you for being here with us. Give him a round of applause. Our next panelist is Phil Darrow. Phil's a senior fellow for the Mathematics for America's Choice, where he focuses on programs for students who are behind in mathematics. Phil chaired the Common Core Standards Mathematics Work Group that is drafting Common Core college and career readiness standards, and was a member of the writing team for the K-12 Common Core state standards. Phil, come forward. So maybe not. Dan Meyer. Dan taught high school math for 6 years to students who did not like math, which is a lot of students. He is currently a doctoral candidate at Stanford University in mathematics education. He speaks internationally and consults with publishers on their digital curricula. He was named one of Tech and Learning's 30 Leaders of the Future and is an Apple Distinguished Educator. Dan Meyer. So this panel is going to consider the mathematics that students must learn in the middle grades. The basic mathematics involved in Algebra 1 mark a critical transition from concrete to abstract thinking and define the gateway to success in high school mathematics and STEM courses. Apparently failing Algebra 1 is a key step toward dropping out. Panel members will focus on 3 issues: the lack of coherence in California's current math curriculum as experienced by students, the essential mathematical knowledge and skills that students need to master in middle grades, and the ways in which the use of digital tools and resources can improve teaching and learning in middle grades. And we're going to start with Neal Finkelstein this morning. Please welcome back up Neal.
Good morning. It's so nice to be here, and I want to thank you for taking your day here, especially pleased to see the educators in the room. And I want to make a special note of thanks to my colleagues at the Silicon Valley Education Foundation and throughout Silicon Valley, both in the school districts in this area and with my colleagues at A-Learn and a variety of other organizations who have allowed me to continue to move forward on what I want to talk about for just a few minutes as a backward map.
But I need to interrupt you.
Please.
Because I didn't do my full job. You know, we have many people helping us here today to make sure we don't screw up. While you're listening, if you come up with questions, we'd like you to write them down and give them to Bob and the SVEF staff. Bob has his hand up over there and over there. So while you're listening, write down those questions. You'll have a chance to get those answers at the end of the panel. Sorry to interrupt.
Great. Thank you, Chuck. What I'd like to do is just spend a few minutes in advance of our next speaker talking about the challenge of post-secondary access in California and the way in which we can tell how important mathematics instruction is in the early years as you make your way towards the post-secondary pipeline in this state. I'm flipping my own slide, so let's get that right. Fantastic. Now, it took me a long time, but it probably hasn't taken you a long time to understand just how important it must be for the preparation for college to start as early as we know it now does. What's taken me a long time is to figure out a way to measure it, and to demonstrate it, and to exhibit it, and to be able to talk about it in ways that I think are persuasive. There are patterns that are available from the higher education segments in the state of California that show us how the eligibility pool for students, in this case by ethnic background, break down. And if you go back to the 1960s, of course, with the California Master Plan, we know that there was a brilliant sort of distinction that the University of California would take the top eighth of high school graduates, top 12.5%. And the California State University would take the top third, and open enrollment through the community college system. And through this integration, we would have post-secondary access pipelines available to students with all sorts of different interests and needs throughout the state. And it struck me years ago, looking at these patterns of post-secondary access, that the patterns for minority students, the patterns for Latino students, the patterns for African-American students were dramatically lower than for white and for Asian students, of course. And how could this be if students were given access to the same rows of courses, the same pipelines through their education? And if you need certain patterns of courses and certain grades in those courses to get access into the University of California or the California State University, then it must be in your preparation that you are becoming ineligible. So we move back and say, well, why? To make it into the University of California systems or into the California State University system, you take a set of courses. You start in the 9th grade. Take a few courses, math and English. You move to the 10th grade, you take a few more, another math, another English, some other A to G courses. And by the time you get to your senior year in high school, you've taken this portfolio of A to G courses, you've climbed the stair step, the cascade is complete, and you're eligible for the University of California or the CSU, depending on your grades and how well you've gone through this linear process. And it turns out it's not linear. And it turns out that students don't take the cascade this way. And it turns out students don't do very well in many cases in this cascade. And therefore, that must be the explanation, quite obviously, as to why some students don't reach those minimal eligibility standards. So we took a look at it pretty systematically. There's a paper that I have available, and I can certainly lead you to that on the West Ed website. Look at 31 public schools, 67,000 students. We look at 12th graders' transcripts. We have 1.6 million course records, and we try and untangle the pattern of how is it that students don't seem to be ready when they finish high school to meet the minimal eligibility standards in the state. And it's a pretty shocking story, but maybe something that you're pretty familiar with. And I'm going to start in 9th grade because, of course, today we're talking about middle grades. And if I can show you and demonstrate to you just how serious the problem is in 9th grade math, well, then we'll spend the day understanding how even more important it is in middle grades. And so go through an exercise with me. There's a very important little red line on these charts. I'm going to start in the upper left-hand corner with a box that says grade 9. And over the number 1, way up at the top, under the number 50, is this little red dash. Can you see it? And if you're a 9th grader in the state of California and you take 1 year of math and you get the grade of a C or better, maybe it's algebra, maybe it's geometry, maybe it's pre-algebra. It should be algebra in order to start qualifying for A to G counts. And you take that 1 year of math and you succeed in that course with a C or better, you earn the credit. And some kids do. All those 9th graders to the right of that little red line do. But if I add up the kids to the left, 31% who didn't take any and 11% who took half, there are 42% of the kids who are off track in math before they finish 9th grade. So what happens if you go to 10th grade? I'm going to add again. I'm on the upper right-hand side of the slide. The red line is above the number 2 for 2 credits in math. And I add from right to left. 16 with 0, 7% with half, 19% with 1 credit earned, 11% with 1.5 credits earned. All these students, for a total of 53% of the students, are off track in math as sophomores in high school. And so you go to 11th grade, and it's the same pattern. I'm on the bottom left, and you add from the left to the right, and it's 10 and 5 are 15, and 11 is 26, and 10 is 36, and 15 is 51, and 11 is 62, sorry, I've done this before. 62% of the students are off track in math by the time they're 11th grade, and so on. I mean, the point is that when you start to look at A to G eligibility patterns and the accessibility to the post-secondary education systems on these eligibility standards, you start in 9th grade being sort of ready to go and you follow onto these downward sloping curves. It doesn't matter from what ethnic group you're from. Students, when they enter high school, continue to lose their momentum and trajectory towards eligibility standards for higher education in the state of California. The paper, which is called Course-Taking Patterns for Postsecondary Access in the state of California, is a paper with lots of downward sloping curves. And that's what I'd like to point out to you as sort of the reason to go further backwards than 9th grade. And so we do, and with generous support and cooperation from foundations, the Bechtel Foundation has been a terrific supporter, the Noyce Foundation, and all of you in Silicon Valley who have made some of this work possible, we start to look at middle grades math trajectories. And I'm just going to spend a minute talking about the math diagnostic testing program and some work that we did understanding how well 6th and 7th graders in this area are doing on math. And these are all about different areas of math. The first bar on the left is fractions and decimals, and the next one is measurement of geometric objects, and the third is coordinate geometry and graphical representation. The next is integers, and so on. These are all constructs in math that get tested separately and are relatively well aligned to the state standards. But spend a minute with me on fractions. Ted talked earlier about how to multiply fractions. And I'm going to demonstrate to you here that if we ask students, on average, to answer a battery of 12 questions as 6th graders to demonstrate their proficiency in handling fraction manipulations, the students get 6.2 of the 12 questions right, or 52% of the questions right on average. Now, this is very serious because this is done with a set of testing, which is adaptive testing, computer adaptive testing, where the harder questions come at the end of the test. So if you can get the first questions right, that's good. The questions at the end of the test are very difficult. But to say it simply, sort of about half the questions are inaccessible to the students in fractions and decimals at the 6th grade level. And so I might want to say, well, how do we know whether that is a serious question in the alignment with what we see as standards in the state of California around math? And with the cooperation, again, of your schools and your colleagues, I looked very closely last year at how it lines up with the CST scores. I wanted to know of the students who were struggling in fractions, see how many of them get 3/4 of the questions right. If you can get 3/4 of those questions in fractions and decimals right as a 6th grader, you're on your way. It turns out that if you're not really proficient and above on the CST, that mastery in fractions is out of reach as a 6th grader. And in our work that predicts college access, going back to the beginning of my comments, it's so clear that students really must be proficient in these early years in order to make their way through math and then beyond. And we're finding as the work continues in an analysis of middle grades math patterns that the trajectories of math students from these middle grades on through high school, looking at their transcript records from 6th, 7th, 8th grade all the way through high school, show many, many, many patterns of students not succeeding early and continuing to not succeed later. And so I asked the question that I hope helps us through the day. How can we communicate to these students and the families and all of us in this room and our colleagues the consequences of deferring the decision to look at college readiness when our students are really 11, 12, and 13 years old? And I find the work in middle grades math instruction to be tremendously exciting, and it really does open up an enormous world of opportunities in reform and instruction. And I really am proud to be here with Phil Darrow and Dan to move us into the conversation about instructional strategies and how important and relevant the implementation of the Common Core State Standards are towards meeting these college readiness objectives by looking so carefully at middle grades mathematics. Thank you so much.
And now the elusive Phil Darrow, Senior Fellow for Mathematics for America's Choice, will speak to us. Phil.
I'm glad Neal had so many nice slides and good data to tell the story, because my slides are buried in my computer, but I don't need them. I was part of writing the Common Core State Standards that California adopted, and I want to tell you a little bit about what we looked at as we were writing those standards and what that has to say about middle school mathematics in California, our policies, our practices, and our realities that Neal just showed you. We were told, I was part of a 3-person writing team. Bill McCallum, a mathematician, Jason Zimba, a young physicist, award-winning writer of a physics textbook. I was the only educator on the writing team. And we were told to base the standards on evidence, not on politics, and to design them so there would be fewer, higher, and clearer. And we were told, in particular, to look at the evidence from high-performing countries, which we did. In fact, we spoke to people from some of those high-performing countries, especially Singapore and Japan were very helpful. And what we saw and what we learned in that evidence contradicts a lot of the assumptions on which California mathematics policy is built. And specifically, if something is important, it's worth spending more time on. In Singapore, they definitely know that. In Japan, they know that. And when you look at the mathematics of middle school, what do you see? I'm part of a study that's currently analyzing the textbooks of freshman college courses, not just in math, all the required courses, in community colleges. These are for programs like nursing, crime scene technician, the 8 most popular programs at the community college. And we've been asked to analyze what mathematics do you actually need in order to understand the textbooks. Then we also look at the midterms and the finals, graded midterms. We actually see the student responses, midterms and finals, and we're asked what mathematics do you need to pass those midterms and finals. The answer, you need to have, be able to use your rates, percents, look at bar charts, graphs, diagrams of all sorts, some very basic algebra, formulas, no manipulation of the formulas, just substituting, and measurement, lots of measurement, especially for the nurses, but also for the auto mechanics. In other words, the middle school mathematics, it's what we have in the grades 6, 7, and 8. So this is actually the most important mathematics for most people who aren't going to be scientists, engineers, or mathematicians, is the mathematics of middle school. Worth spending more time on. When you look at the National Math Panel report, surveys of college faculty, any source of data you want, you ask for four-year college majors, four-year college students, what's the most important mathematics? There's a resounding and almost unanimous answer, Algebra 1. Nothing's more important. In fact, if you look at the survey results, what college faculty seem to be saying is, teach 4 years of Algebra 1, we'll teach the more advanced stuff. We have students who've got 5s on AP Calculus who don't understand Algebra 1. And we wish you had taught them the distributive property instead of calculus. That's what college faculty are saying. Then you look at the A to G requirements, requirement C that Neal was just talking about. To be eligible for UC, you have to complete Algebra 2 by the time you graduate from high school. That won't do, of course, if you want to be a STEM major, but a humanities major, a business major. That's only 3 high school courses, Algebra 1, Geometry, Algebra 2. You have 4 years in high school. So my question is, what's the hurry? Why are we spending less time on the most important mathematics? When we push algebra down into 8th grade, what we're saying is, let's spend less time on middle school math, which is so important for most people, and less time on Algebra 1, which is the most important math for college, 4-year colleges. Why did we decide we want to spend less time on the most important math? It doesn't make sense. When you look at if I had my slides, I would show you the Singapore standards, but you can get them online. The Singapore Ministry of Education website's in English because they teach all their students in English. And if you look at those standards, look at algebra and functions. They have it split up into those two. Over grades 7, 8, and 9. And I'll just give the example from how they deal with the quadratic. In grade 7, this is how far they go. X squared means x times x. X cubed means x times x times x. Basic idea of what an exponent is for a whole number of exponents, and they stop at x cubed. In 8th grade, they do the simplest factoring of polynomials, x plus 1 times x plus 1, x plus 1 times x minus 1. That's it. The ones that are easiest, technically least demanding, the calculation almost does itself. And it's not until 9th grade, all you math people will know what I'm talking about, the rest of you will remember what it felt like when you did it, completing the square and the quadratic formula. They do that in 9th grade, not 8th grade. And Singaporean 9th graders are 6 months older than our 9th graders. So this content in the traditional, the old California standards was compressed into 1 year. They spread it out over 3. It's so important, they spend more time on it. In the Common Core standards, as they were written, we spread it out over 2 years. California, in its revision, compressed it into 1 year. It makes no sense. Maybe if we were having great success with this scheme, which we've been trying for a decade now, it would make sense. But I think Neal just showed you it's chaos. So one of the things that I'm urging is simply spend more time on the more important math. It's not true that more advanced math is more important than less advanced math. The arithmetic of complex numbers is necessary if you're going forward in mathematics, but it's not more important even if you're a mathematician than Algebra 1. Being more advanced does not mean being more important. And what we learned looking at the high-performing countries is not that their standards were higher than ours. They weren't. Malaysia's standards are a lot higher than Singapore's. Singapore's standards are, performance is a lot higher than Malaysia's. What we saw in Japan, Singapore, Finland, is that their standards are close to their population. The performance and the standards are closely related. And they historically adjust their standards down to meet their kids. So one of the things we noticed was dividing fractions by fractions was in 6th grade in Japan and Singapore. We had it in 5th grade. So we asked them why. They said, oh, well, we had it in 5th grade and it wasn't working. Long pause on our end. What do you mean it wasn't working? What does it mean that when a standard isn't working? So we said, what do you mean it wasn't working? Long pause on his end. He said, well, a lot of students weren't learning it. You can't just have a standard there when a lot of students aren't learning it. You have to do something. What's going to happen the next year and the year after? So what did you do? Well, there's only 3 things you can do. We can remove it from the curriculum. And they have done that historically to a lot of things. It's one of the reasons why their curriculum is more elegant than ours, has less in it. Our curriculum, if you don't know, is the cause of our low performance in math, not our pedagogy. And the cause is summed up in the phrase, a mile wide, inch deep. Mile wide, too many topics. How did Singapore get less topics? They took stuff out. So they apply the remove the brick and see what falls criterion. And when they applied that to dividing fractions by fractions, it would make the understanding of rates, which was coming up, incomplete, and so they could not remove it from the curriculum. The other 2 options they had were remove something else from the curriculum in that grade level and tell teachers to spend more time on it, or move it to another grade level, which is the option they chose. And then he said, and now it works. Most kids are learning it. So we put dividing fractions by fractions in 6th grade. So the bottom line from what my message is, how to fix middle school mathematics, is to have fewer topics taught during these 3 years and teach them well, the way they do in high-performing countries. And in order to do that, we have to change state policy and move Algebra 1 into high school, where the better trained math teachers are. We still need acceleration for some students, and there's a few comments on acceleration. And I think we have a couple of options for acceleration. Underlying all this, of course, is the social justice issue. There's an underlying problem that every teacher faces, and we face systemically, of the differences among children in their interest in, their ambitions for, and their readiness for mathematics. And how do we manage those differences when we have a social justice agenda? The solution, the old solution to that problem from 20 years ago, I need to wrap up, was that old solution was tracking, and that didn't work. So we stopped tracking as a matter of official policy, but the problem didn't go away because a failed solution was removed. The current solution, Neal showed you, is also not working. We have to move to another solution. Acceleration at the high school level makes a lot of sense compress 3 years in 2. You have the teachers who could do it. The kids would still be able to take calculus in high school, and there'd be plenty of time in middle school for kids to learn that important mathematics. Okay, so with those thoughts, I'm wrapped up.
Thank you. And now Dan Meyer, a math teacher and graduate fellow.
Thanks. I could ask you with that photo how tall you think that lamppost is, just to give a guess. I could ask you to give me a guess that you know is too low, too high, a wrong answer, if you will. I could then ask you, what triangles do you see on this image now? How many? What types? Where are they? And once you point out certain triangles that you see, I could ask you, do you notice anything special about those triangles? Are they just arbitrary, random triangles drawn here or there? No, there's something special about them, you tell me. They're mathematically similar looking. And I could ask you to, how do you know that? Could you help me prove that? And we know that if you have 2 angles that are the same in 2 different triangles, they are mathematically similar. What 2 angles in each of those triangles are the same? Can you help me with that? And you might point out to me that all of these angles are the same. In fact, they're all 90 degrees. Because you tell me we're all standing perpendicular to the ground. Even the lamppost is. You could point out that these angles are the same. Why? Because the sun's rays all strike us at the same angle, because we're all in more or less the same spot. So we have these similar triangles. And I could ask you, what parts of these triangles are easier to measure than others? And we could have that conversation. You might point out that our heights are all known, except for the lampposts, and our shadows are all fairly easily measured. And at this point, you could solve for that unknown height. We've just gone from the concrete to the very, very abstract, you and me, in this process together called mathematical abstraction, where we formalize the informal. It's a process that is invaluable, something that mathematicians do all the time. It's engaging to students and accessible to students at every level. If I could think of one way to restrict access to math to the already haves and close it off from the have-nots, I could do no better than to rush as quickly as possible to the highest level of abstraction as possible on this scene. And that's, of course, how we see this problem in even highly regarded textbooks. Like right here, I can't ask you, what triangles do you see? That triangle has already been abstracted. I can't ask you what information is easiest to gather here. It's already there. The problem, as I perceive it, is print. Like the process that we went through, stepping that out gradually, you and me, that required 10 extra slides in a slide deck. That cost me a few bits and bytes on a hard drive. It's nothing. But printed pages in a textbook, 10 extra of those, that's very expensive. So I'm here today very optimistic about digital curricula and its ability to open that process of abstraction up to all of our students. That's not to say this process couldn't go horribly, horribly wrong. So I just want to point out here, to close it up and turn it over to you guys, that print is a medium. You know, same as digital photos, same as a teacher's voice, same as a YouTube video, same as a podcast. These are all different media. And as we know, the medium is the message. The medium defines and constrains and sometimes distorts the message. The math that can be conveyed in a YouTube video is not the same math that can be conveyed in a digital photo or a podcast or a print textbook. We're so enthusiastic here in the Silicon Valley in this group about technology that disrupts and scales. But I think it's really important to point out here the fundamental misapprehension of this whole process of technology that we have is that there is one monolithic mathematics, and we are all just innovating around mathematics. But those innovations distort what mathematics is. That's the ball that I urge us all to keep our eye on today. I'm really excited to be here and tease apart those issues with you and take some questions. Thank you.
Well, I wish we had another hour to ask a lot of questions. We already have 9 questions posed, and I've tried to consolidate them into a question that each of you can respond to if you wish, and then we'll try to pull some others from here if we have time. But one of the themes that I see in the questions here is about the Common Core standards. So how will the Common Core standards, paired with the computer-assisted adaptive assessments that are envisioned by the Smarter Balance Consortia, change or disrupt middle grades mathematics, in your opinion? Who wants to take that? Phil, you want to start?
Well, I think, is this on?
It is.
Yeah. I think technology has changed the game entirely, and textbooks are going to disappear sometime in the next decade. They already are at higher ed levels in a lot of courses. And the thing about technology is something cool comes out every week. There's cool stuff coming out all the time. The idea of a 7-year adoption cycle is nuts now. We need a weekly adoption cycle or a monthly at the most. And so I think we have to, and this is happening because of technology. The Common Core standards, because 46 states have adopted them, have created a market that's worth building stuff for. And so stuff that's built in Delaware, where they haven't stripped their education system to the bone, they're using the same standards we're using here in California. We can use the stuff from Delaware. If you're an entrepreneur, if you build something, you can sell it in 46 states. You don't have to go through some kind of 50 states is each a different market process. So it's drawing a lot more innovation than what we've had before. So I think being part of this national process is going to make a big difference, particularly with the rapid cycle innovation that technology brings to play. And just the final note, kids will have direct access to so much stuff, the role of school has to change. And particularly in mathematics, there is already a lot of free stuff out there, and it's swimming in the ecosphere. That doesn't mean kids will pick good stuff and learn the right math. I mean, the role of the school is still going to be very essential, but if school has a wall between what's going on in the technology world and what goes on inside the school, it's going to be, it's really going to be sad. So we have to open the windows and let technology in.
Dan, do you have a comment on it?
Yeah, I like the Smarter Balance assessment items, particularly their printed items. That's kind of, I guess, controversial to say at a tech conference, but the stuff that you can assess online is just different. It's someone I admire says that the computer is not the natural medium for mathematics, not yet. There's not natural language processing. You can't easily grade automatically and adapt to a written argument that the student makes about some figures that he says are similar, for instance. So that's stuff that I would feel sad that if we lost those in our hurry to get to computer-adapted testing.
Dan, haven't you developed a set of videos around, didn't I see you on Class Action doing an example of some videos you'd created that demonstrate mathematical concepts?
Right, yeah, some illustrations.
And those available online?
Yes.
Do you want to tell people where you can find them?
The voice is a very poor medium to describe URLs to the internet, unfortunately. Blog.mrmeyer.com, M-R-M-E-Y-E-R.
Thank you.
Yeah.
Comment, Neal? No. Okay. So a follow-up to that, and another question we have here, is if indeed the Common Core are designed around a continuum of learning, how will it change instruction, grouping, schools, even the concept of middle school?
Again, I'm going to appeal to insights from Asian practice. We asked why long division was in the curriculum. This is Japanese. Not that we weren't going to include it, but there were a lot of people who said don't include it. It's not necessary. And what he said was, we teach long division because there's so much unfinished business about place value. Fifth graders don't really finish learning place value until long division, and long division is an excellent way to surface all the issues in place value. So we finish teaching place value while we're teaching long division. American teachers say, I can't teach long division. They don't know place value. They're supposed to know place value before they get here. The point is, every math problem Every math lesson is a window through which you can see all the preceding mathematics. When you learn something in third grade, you don't just use it in third grade. You still multiply when you get to calculus. You're still using third grade math. And we have to learn to look back along that progression and teach today's problem in a way that reaches back and finishes the business from earlier grade levels. What we usually do is, oh, they can't do the problem, shut the book, reteach, put them in a remedial. That's not the first line of defense. The first line of defense is to build that progression into today's problems. And I think what we need is teachers and teacher prep that looks at the whole progression, not just at the grade level.
Any other comments? Neal?
Just a brief comment to add on. There's a range of ways in which we adopt the checking for understanding of students as they're moving through their progression in mathematics. And for those of you who are in the classroom every day, and for those of us who have the benefit of observing and learning from you in the classroom, there are so many ways to check for student understanding. And what I think we see is checking for understanding at some fundamental level realize that there isn't thorough understanding among many students, and then moving along on a pace that requires us to leave those students not able to cascade forward with a solid and concrete foundation. I think one of the opportunities for the Common Core is that the articulation really is of the learning strands. And then the challenge, of course, is to adapt and adopt an instructional method and a way of circling back once or twice or three times with changes in time, changes in duration, changes in the way that classroom structures are organized, changes in the way that specialization of instruction is optimized, to make sure that that understanding allows students really to move forward along the standards as they've been suggested by Phil and others.
So, Neal, while you're speaking, there's a specific question for you. Do you agree with Phil's conclusions about data, i.e. the solution to spend more time ensuring kids learn Algebra 1? I guess we're trying to build a little controversy on the panel here.
Our analyses of these transcript records, which are now have been done in several different ways in lots of places on local districts and on state representative samples of districts, they show the variation that Phil suggested when Phil said that there was a challenge, framed it in the social justice context, about the way in which students should be accelerated versus maintaining sort of a different trajectory at a different speed. And I would suggest that it's the most important thing to wrestle with, is finding the correct pace, finding the correct pacing, and finding the ways in which we consistently measure students' understanding in content before they move on. It can be done in countless ways, and there are demonstrations of those innovations every day in this state. But I wouldn't like to say that we've kind of figured it out, what the exact formulation of course and course structure is, and I think the Common Core State Standards help us get there. What is true is that the existing array of courses, the alignment of curriculum in those courses, the use of instructional materials, and the variations within those as they're brought into each and every classroom, the variation is almost infinite. So many different ways, so many different paths, so many different configurations, so many different stories and winding roads that students are on. And it seems as though, at a minimum, it makes the communication fuzzy and makes the connection between standards and instruction more difficult. So I think we're in a place where we really do have an opportunity with the Common Core State Standards to add some clarity to this area.
So we have many, many questions, and I want to tell you, so you won't be frustrated about submitting your question and not getting it answered right now. We will keep these questions active and maybe use them with other panels as they are appropriate. So we will hopefully get to your questions. There's another thread of questions here, though, that I'd like to open. I'll maybe start with Dan on this one. It's a series of questions about what kind of support are teachers and schools going to need to transition to Common Core, to make the changes in middle school math. Should the state be providing some support, county offices, or should foundations be providing that support? So, you want to take any piece of that on?
Yeah, sure. Most of the PD that I underwent as a teacher stayed very close to content. It was 1 or 2 degrees removed from how do you teach content, and now that we have these practices in the Common Core, that opens up an entirely new PD challenge. And I think that the PD that I facilitate, the most effective ones, I've facilitated some very ineffective PD, I'll admit that, The effective stuff has always included a large component where we do the practices. Because teachers, I think if you've taught for 30 years under a particular style of teaching, it has to distort what your perception is of math and how it should be taught. It's unavoidable to be steeped in that for so long. And so to realign yourself, I imagine it's a very difficult thing. So PD that involves problem solving, involves reasoning, argumentation, that'll be essential going forward.
Other comments by other panelists? With that, then, we will close this panel, and with any final comments any of the panelists have. Your final shot. I knew Phil would take this.
I think on the questions I raised, I would agree with Neal. The most important thing is to open the question and stop standing pat on something that doesn't work. I'm sure there's a million ways to solve the problem better than we are, but we won't get there unless we realize it's a problem and open the question.
Neal, final comment?
My final comment would be that the data can be extremely helpful if used not only for large, robust studies, but also taken down to the district and site level. And I would look forward to the years ahead where there is an opportunity for developing tools and techniques for, in the spirit of the kind of ideas Ted was suggesting, where the pathway that students are taking through their instructional gains are made helpful and useful to all of us, the classroom teachers and site leaders, to make sure that instruction really is customized and reaching students as they need it, when they need it.
Dan?
No, thank you, guys.
Okay. With that, as you can see, this is a time of great change and great opportunity. Let's give a round of applause to the panel for sharing their thoughts with us today.